Okay, so we go to number 3. Alright, so we've got a situation. 2 posts, one 12 feet high and the other 28 feet high, stand 30 feet apart. They are to be stayed by 2 wires attached to a single stake running from ground level to the top of each post. Where should the stake be placed to use the least wire? Okay, so a picture is very helpful for this one. So you've got level ground, and you've got one pole that's only 12 feet tall. And you got another one 30 feet away. And it is 28 feet tall. And you're going to put a stake somewhere between here. And you're going to run a wire to the top of each pole. And it is possible, I guess I should say this, it is possible that if you had your 2 poles, it is possible that you run your wire all the way to the edge of that one. And then you could just do Pythagorean theorem. So if we did that, 30 squared plus 28 squared, to give us this, we'd take the square root. And we'd get, let's do 3. And we get 41.0366. You also could run the wire like this. And so that would be 12 squared plus 30 squared. Actually, no. You'd have this plus you'd have to run the wire. The wire would have to run like this. So you'd have to have that 41 plus 12. And so that, if you did it this way, that'd be 53.036. If you do it the other way, you'd have the square root of 12 squared plus 30 squared. So this length would be 32, but you'd have to add that 28. So you have to add 28. And so you get 60.311. Between the two, it's better to run the wire like this, but probably there's somewhere in between that would be the best place to put the wires so that it's going to use the least wire. Plus, I just feel like this would not be very stable right here, because usually those wires are trying to stabilize the poles. So, I'm going to label several things here. I'm going to call this piece of wire X. And I'm going to call this piece of wire Y. And so we are trying to minimize the amount of wire that we have. So I'm going to make that equation W, which would just be X plus Y. Alright, that's what we want to minimize, is the amount of Y. But we are not going to be able to solve this with an X and a Y. Okay? And in fact, we can't really do it in terms of X or Y, because this X over here has nothing to do with the other equation. And this Y has nothing to do with the other equation. So what we've got to do for this one is I'm I'm going to let this piece right here, I'm going to let it be, I'm going to call it A. And the reason I'm doing that is because if I've called this something, then I could do a squared plus b squared equals c squared, and I can solve that for x, right? Over here for the y, I need to know this side. If this part's a, and the whole length between the two poles is 30, what could I call this piece at the bottom of this triangle? 30 minus a. So, I know that a squared plus 12 squared would equal x squared, right? So I could take the square root of both sides there, and a squared plus 144, or square root of a squared plus 144 would equal x. So I'm going to add that over here in this equation. A squared plus 144. And I could do the same thing over here with the y. It's a little trickier because I've got 30 minus a, so I'd have 30 minus a squared plus 28 squared would equal y squared. And so I could square root both sides there. So that's going to be, let's see, we'll have 900 minus 60a plus a squared plus 28 squared is 784. That equals my y. If we simplify that a little bit more, we would have a squared minus 60a plus 1684. And that's my y, so that can go here. A squared minus and let me think. Let's make this one calculator active here because this is going to take a while. Newer AP questions, they typically don't ask you to do a lot of this extensive stuff by hand and then do the other parts of it. So let's just make this calculator active. So we need to take the derivative of square root of x squared plus 144 plus the square root of x squared plus minus 60x plus 1684 comma x. I'm not going to write that down. So this is our derivative right here. Whatever that is, you can see why I decided that we should just do this one calculator active because it's really lengthy. So we've got all of this stuff. This is our derivative. Your calculator will let you copy and paste. So I'm going to go up here. I'm going to hit the green button and then that up arrow that copies this. And so I want to know where this equals 0. I could do that either from the graph or using the solve feature. It really doesn't matter. I think I'll use the graph. Oh, maybe. Let me go back. I might have it wrong. Yes, I thought I did and I did not. Let's fix that. Okay, maybe our derivative might not be quite so bad. It's still pretty bad, but maybe a little less bad. So let's copy this one And let's go to y equals, and let's paste that there. So you use that copy and paste so that you don't have to try to write all that down and type it. So we're looking at the derivative here. If we go to the graph, and notice I don't really see anything right here, because what we're graphing is we're looking at A is what we're trying to find. What is the very least A could be? The very least A could be would be like in this situation, and it would be 0, right? What's the most A could be? The most it could be would be 30. So let's go to our window, and let's change this from 0 to 30. And now let's graph it. And you can see it looks like we only have one place right there where we cross from negative to positive, which would give us a minimum. So we just want to find that 0. So F5, 0. And we get 9. So A would equal 9. And so we would want to say 9 feet from the base of the 12-foot pole. And the question doesn't ask us how much wire that is. If they did, you could just type it in real quick. I'm kind of curious just because I want to see how close it is here. Let me see if I can do it real quick. 9 to the second plus 144 plus square root of 2 second 60 times 9 plus 84. And so you get 50 feet of wire exactly, which is less than either one of these. Okay. Questions other than why a crowd of hoodlums is being so loud in the hall? Okay, let's look at the last one. Okay, so we've got 4 feet of wire, and we want to use it to make a square and a circle. How much of the wire should be used for the square, and how much should be used for the circle to enclose the maximum total area? So, a square and a circle. And so the wire is going to be this outside edge. So I'm going to call this right here X. The perimeter of this form is going to be 4X. And then I'm going to call the radius of this Y. I wouldn't call this perimeter for a circle. I'd call it circumference. How do I find the circumference? Is 2 pi r, or sometimes we'll say pi times diameter. So 2 pi r, 2 pi y. And I know these two are the perimeter and the circumference. So if I add them together, 4x plus 2 pi y. That is the total length of wire that I need. And how much wire do I have? 4 feet. Okay, so I know I've got this equation. This is not the equation I'm trying to minimize. I'm trying to minimize the maximum total area, or maximize the total area. So if I'm looking at the area for these, area here would be x squared, area here would be pi r squared, or y squared. I guess I could have called it r. So my area formula would be x squared plus pi y squared. We cannot do this when we've got x's and y's in the equation. So we need to use this equation right here to solve for either x or y and plug into this equation. It does say how much should be used for the circle to enclose the maximum area, so maybe we should solve for x so that we can have y's in our equation. It really doesn't matter that much. So I don't know, x looks a little easier to solve for. Let's just solve for x. So we've got 4x would equal 4 minus 2 pi y, and then we divide by 4. So x equals 1 minus 1/2 pi y. So we would have 1 minus 1/2 pi y squared plus pi y squared. And so, let's see, down here we got room. Take this over here. Alright, so let's write this as 1 minus, is it okay with you guys if I call that pi over 2y? And we'll write it twice. Plus pi y squared. So I'd distribute here. I'd get 1 minus pi over 2y minus pi over 2y plus, right here, you're going to get pi over 2y. The whole thing will be squared. So we've got 1 minus, you got pi over 2 and pi over 2, so if you put that together, you get 2 pi over 2, which is just pi. So we get pi y plus pi squared over 4 y squared plus pi y squared. Even though these are both y squared, it's going to be a little difficult to put them together because you got this pi squared right here. So I would probably just leave them separate as they are right now. Okay, questions so far? Alright, so we're going to take the derivative, so a prime. The derivative of 1 is just 0. The derivative of negative pi y is just negative pi, because pi is a coefficient. Here, we'll have 2 pi squared over 4 times y to the first power plus 2 pi y. So we've got negative pi plus pi squared over 2y plus 2 pi y. I wish this was easier. We would set this equal to 0. It's not too bad. It's going to be a really, really ugly answer. But it's not that hard to solve. So to solve this, you would add the pi right there. And so you'd have pi squared over 2y. Hunter, please quit. And then you could factor out the y, so you'd have pi squared over 2 plus 2 pi equals pi. This is really ugly. I might should have just made this calculator act. It's not that difficult to do. It's always pi. So you divide by pi squared over 2 plus 2 pi. And so y would equal pi over pi squared over 2 plus 2 pi. We're definitely not going to simplify that any further, although we do have a complex fraction there. Okay, questions here? That is our 0. So I'm going to type it into the calculator just to simplify it. So pi over pi squared over 2 plus 2 pi. Let's see if it does anything here. 2 over pi plus 4. Let's use that instead. 2 over pi plus 4. So this is 2 over pi plus 4. You could plug in a number like 0 down here. That's less than what we've got here. And that would just, if you're plugging into the derivative, if you plug in 0 for those y's, you're just going to get negative pi. So it's negative here. If you plug in a number bigger than 2, like 1 would probably be good, you would get negative pi plus pi squared over 2 plus 2 pi. And I don't know what number that is, but I do know it's going to be positive because this part's positive and 2 pi is bigger than negative pi. So you'll get a positive here. So you have this 2 over pi plus 4. Let's see what that is as a decimal. So 0.28005 would be the radius of that circle there, and then so you can figure out how much you need for the square if you want it there. I guess we should do 2 pi times this number. And so you'd be using 1.75 for the circle, and then you'd use whatever's left for the square. Questions on that one? Okay, tonight's homework, I want you guys to finish anything you didn't get done on that worksheet that I gave you at the beginning. And then we are going to do page 262. And we'll do 19, 21, and 37.